Friends, good evening to all of you. And it says, write in your heart that every day is the best day and enjoy it. So today is the best day for all of us, and let's enjoy it with good learning. So friends, welcome to the session on logistic regression. Okay, so that's the agenda for us for this particular session. But we have to go through this session with the mindset to learn, and that too with understanding. So we have to learn, and we have to learn with clear understanding of the things which we are talking about. Okay? And as I said earlier, if you remember, don't hesitate in asking questions. Anyone can stop me anytime and throw the query and the questions. Either you can unmute yourself, talk to me directly, or you can put your queries in the chat box, and I'd love to answer those queries. But don't hesitate in asking questions. What is important for us is understanding and clarity. But before we proceed further, a question to think. What is most important input which we require for our research? Think. And when I say research, I'm talking about scientific research. For us who are into social sciences, what is the most important thing which you believe, which you think is there for every research? Without that, it's not possible for us to do any research. Any one of you? Quick.
Curiosity.
Hello?
Curiosity, sir.
Curiosity, okay. Swapnil, what else?
Scientific
Yes.
bent of mind.
But how that bent of mind is developed?
Yeah.
How do you know that you have to do research? What is that which prompts you to do the research?
Something which is unknown.
Right. So how do you know that it is unknown? There are so many things which are unknown, but why a particular thing we have taken as an unknown thing which we have to research? Is it the idea which is more important, or is it the data which is more important? The software which is to be used for research is more important, or the tools do you think are more important? You need all of them. I'm not denying that you don't require data, you need data. I'm not saying that you don't require software, you need software. You also need tools to do the research. But out of these, which one do you think is most important? Anyone? Quick?
Is the idea?
Yes, it's the idea. It's the idea which is important. If you don't have an idea, you don't know what is to be worked on. So the most important thing is an idea. Idea is important because that is something which is motivating us. That is something which is compelling us. That is which is forcing us to do something. And that's why we say that idea is very, very important. Of course, I'm not undermining the importance of the data, software, the tools which you need for your research. But the kicking point is the idea with which you have to work. Yes, Rashika and Janita, they all say idea. And Sukanya is also saying idea. And Rashika, critical thinking gives you that idea and helps you in developing the idea. Idea gives research issues and research problems for which we are trying to seek answers. So idea is one of the most important triggers and motivators that will always be with us throughout the journey. Keep ideas. What exactly you want to do, you must be clear, and that idea which you have in your mind will help you in crystallizing your research problems and research issues. And always curious, full up. So, curiosity is also very, very important for us. Sorry. When we discuss some topic in econometrics, we should have a motivation for the same. Why? Logistic. Regression. We must be clear in our mind what is that for which we want to study this particular topic. Let me just check who's here is not you. Who's that? Mageshwari, please mute yourself. Mageshwari.
I'll just.
So, whatever topic we are discussing, we should have a motivation for it. Why do we need to study this? The only thing we must appreciate what is that we want to study in this topic. So, any one of you have any idea what is that we are going to study in logistic regression, logit regression, and logit, logistic, profit, all those things? Any one of you? Binary responses. Rashika, what kind of binary responses do you have, Rashika? Please.
Sir, like So in a survey, sometimes we need to record the responses in yes or no.
Right.
Then we give 1 in yes and 0 in no. Then, sir, that is a binary response.
Right. Rashika, is that the dependent variable or independent variable?
Sir, independent variable.
So the responses which are collecting in responses, I agree with you, they may be of binary nature. Okay. But
sir.
the question is, are they dependent or they are independent? If they are independent, then there is no need to study logistic regression. But if they are dependent, then there is a need to study logistic regression. Logistic regression is used when our dependent variable is binary variable. And there are instances where we find that my dependent is a binary. Look at this penalty shoot video. Guess, will this player score penalty? Can you imagine what are the factors one should use to predict whether a penalty shoot will be converted into a goal? Can any one of you think? Is it possible for us to predict whether a particular player is going to convert a penalty shoot into a goal? So what we want, goal, no goal, binary, dependent. And it may be dependent upon the anxiety level of the player, stress of the player, okay, the concentration of the player. There may be a number of factors which is impacting the result of a particular penalty shootout. Let's take another example. For this purpose, some data was collected and 75 football players were selected random, and before taking a penalty kick in a competition, they were given a state anxiety questionnaire to complete. Okay, and these players were being asked to complete a questionnaire to give a measure how much they worry about things generally, and their past success rate was obtained from data. And on the basis of which they try to predict whether a particular penalty shootout will be, result into a goal or not. If you see here, penalty missed, these are the penalty score. Two groups. Of course, there may be some overlap, but at the same time, there's a clear-cut distinction in the behavior of the penalty missed and the penalty score. And how to analyze it, that's the problem. How to model it, that's the problem. Depends upon a number of factors like percentage of previous penalties record, questionnaire data measure their degree of worry, and the result of the penalty kick. Have you ever thought that what are the factors which improve the chances of making a merger successful? Sukanya probability, Dr. R.S.P. Singh talks about win and loss. That's true. What are the factors which improve the chances of making a merger successful? How do we know this? So we know that mergers will be either successful or, and the success and the failure may be a function of number of variables. How to establish that relationship? That's what we are wondering. Have you ever thought that, what factors make a person to invest in the stock market or not to invest in the stock market? Swapnil Shah is saying cultural similarity. Okay. I don't know in what context is saying cultural similarity. Okay. Mergers, I think. Yes.
That's right, sir.
But Swapnil, how to prove that cultural similarity is important factor? Maybe something else?
That's right. Yeah.
It may be possible what you say is important, but how do we prove whether it is important? And if you cannot prove it, then nobody will accept that. You have to prove what you are trying to say. Just a minute. So मैं बाद में कॉल करता हूँ. Have you ever thought that how Gmail is deciding what mails should be put in the input, your inbox, and what should be put in a spam? A mail is coming in, and how Gmail is deciding whether it should be put in inbox or spam. How they do it. Numerous recipients go to spam. Yes, Dr. Parne, that means there is a possibility of error. And many times you'll find your important mails are being put in a spam. So whatever process algorithm they're using, that's not 100% correct. But majority of the time you'll find it's correct. So what are the characteristics they find for a mail to decide inbox or spam? Imagine what if the dependent variable is a binary variable. If you're looking for the answers to these questions, then we have to study what is called a linear probability model, logic model, and profit model. And that's the agenda of our session. So now we shall talk about a regression model with dummy, qualitative, binary, limited, value dependent variable. So y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus x1, x2 may be your scale level variables or maybe dummy variables. But what is important for us is y, dependent variable. This is my binary. Anybody, Rishika has a question. What is a dummy variable? Dr. Panay Prashar is saying dummy can be constructed as a hypothetical variable. Dr. Parne, it's not necessary that your dummy variable is a hypothetical variable. It may be a realistic variable. Say, for example, big size companies, small size companies can be modeled by dummy. And suppose you want to see the impact of the global financial crisis. Okay, then this crisis can be modeled by using a dummy variable which takes a value 0 and 1. 0, no crisis, 1, crisis. So it is not necessary that they are hypothetical variables. They may be very much real variables. But the property is that it will take binary values. Either it exists or it doesn't exist. Rashika, is that clear?
Yes, sir. Sir, I wanted to ask that what is the need of a dummy variable? Why do we use it in research?
Rashika, can you tell me what is the area in which you are working?
Sir, my area is financial literacy.
Financial
Literacy.
literacy. Do you think gender has an impact on the financial literacy? The financial literacy between women and men will be same or different?
Sir, different.
What does it mean? Financial literacy is a function of gender, isn't it?
Yes, sir.
How to model gender? You have to make a model, you have to make equation. How to do that? How to do that? For that, we take help of dummy. We define 0 for male, 1 for female. And that's how we use it. Okay. Do you think the background also makes impact on the financial literacy? The rural background or the urban background?
Yes, sir. Yes, sir.
How you will model it?
Sir, for rural, I'll give 0, and for urban, I'll give
That
1.
means you are using dummy.
Yes, sir.
So there are many instances where you use dummy variable, which are representing some qualitative aspect, which either exists or it doesn't exist. Okay?
Okay, sir. Thank you, sir.
So what we are saying that y is my binary variable. So if my y is a dummy variable or a binary variable, then we make use of what is called linear probability model or probit model or the logic model. We shall start with the linear probability model, then we move to logic and probit model.
Sir, I have a question. Can I ask you?
Yes, Anjali, please.
Sir, in earlier slides, you said that y1 is an binary term. Like, so binary, it means that it is dependent on 2 factors. That is why it calls binary, or
No.
it is in itself is binary.
It does not depend upon 2 factors. Its value itself is 2. It takes
How
2
can
values.
x1, x5, like x and
Y is
x2?
taking 2 values, either 0 or 1. But it may be a function of x1, x2, x3, x4, so many variables.
Okay.
So these are the factors.
Yeah, That is why it is called binary.
No.
Is binary because
It
of
is
0
called,
and 1
it
value.
is because y is getting value 0 and 1.
Like hypothesis, null or alternate.
No. We are not testing hypothesis right now.
So how can 0
Anjali, you tell me what is your background. I will try to answer your question from that background.
my is organizational behavior.
Okay. Okay. Attrition rate. Suppose I'm working on the attrition rate in a particular organization.
Okay.
Do you think attrition rate is different for different gender?
The product price. What you said, sorry.
Hmm?
So what you said, I can't hear. There are some issues.
Attrition rate, you understand? You understand attrition rate? Turnover rate.
Okay.
This attrition rate is a function of what? Gender.
Okay.
Now, in this example, attrition is my scale variable.
Okay.
This is my independent variable. If it is a case, then I use simple OLS.
Okay.
But if I take a variable, okay, suppose you have a recruit. And you want to know whether this person will stay in the organization or will not stay in the organization for the next 5 years. If he doesn't stay, I call it 0. If he stays, I call it 1. Whether he will stay in an organization or not depends upon what? Salary structure, leadership style,
Culture of the organization.
culture. So what's happening? You are trying to see the impact of these variables on a binary variable.
That is entirely dependent.
So in that case, we have to use logit, probit, or linear probability model.
Okay.
So now you can see 2 examples I've given, where my dependent is scale, where my dependent is binary.
Okay. Okay, fine. Thank you, sir.
Sir,
Weighted or not, yes, Prasha, that's also there. Shital, I don't know what you mean by 0 job satisfaction. I don't know.
Sir, that was a typo error. 0. I meant job satisfaction also is a contributory factor.
Okay. Why do we need a separate discussion on a model with binary dependent variable? Why can't we use simple OLS? If I take y is equal to alpha plus beta x plus error 2, this is binary. Why do we need a separate discussion? Why do we need a separate topic on it? Why can't you use simple OLS and feel happy?
Because it is non-linear.
How do you know it's non-linear? It's linear. It's linear. It's not non-linear. Yes, come on.
Dependent variable on binary. So
So,
that's why I said it is non-linear.
no.
No? Okay.
You may have two parallel lines, that's maybe possible, but linear. Let's consider a problem, and somebody is working on bankruptcy, and he took these ratios. So if a firm is zero bankrupt, if it is not, it's a sound company. So we have zero, that means the company is bankrupt. One means the company is solvent. And suppose it gets the value 0.75. How do we interpret this? Bankruptcy is alpha plus beta of 1, say PAT, plus beta 2 working capital plus error. I'm not writing anything. So when I did regression, what I observed that this variable gets a value between 0.75. My input is 0 or 1, but my estimated value is 0.75. What is this value represents? What is that value represents? I take a simple example. Y is equal to alpha plus beta x plus error term. Ordinary regression equation. When we estimate it, what we get? Any one of you? When you estimate, what you get? Estimated value of y, alpha hat, estimated value of this, estimated value of beta. That's equal to what? Sheetal, can you mute yourself?
Please mute.
Sheetal, mute yourself, please. Yes. What is that we get? What is this estimated value? Y hat. What is this estimated value? Y hat. Anybody? This is nothing but
Estimating the dependent variable.
expected value of y given x. For a given x, this is what we expect. Whenever you get any value of estimation from your regression, that always the expected value of y given x. So 0.75 is nothing but expected value of y given x. But how do we interpret this expected value of y given x? That's the challenge. What does it mean? Anybody? Why? We know that for a given x, it can take a value 0 or 1. Anyone tell me, how do we get expectation? What is the expectation of x? Anybody? What is the expectation of x? Quick.
So it is 0.5 means it is near to 1. That way we can group.
Who was that? Saloni was there? Who was that?
Sahifa.
Sharifa.
Yes, sir.
Okay. Sharifa. Okay. Sharifa, how do we define expectation? What you say, that's the interpretation. But how do we calculate expected value? Sahifa. Yes, Sahifa. How do we get expected value? Quick. It is summation of x into probability of x. So if I want to get the value, expected value of y given x, then I need probability. Suppose probability of getting 1 is p, 0, 1 minus p. And to get the expected value, multiply y into probability of y, 0, p. What does it mean? Expected value of y given x is nothing but probability of so when I say 0.75, 0.75 is the probability that my y will take a value. That's how do we interpret this. So what this equation means, if the estimated value of the dependent variable group is 0.75, and how do we interpret this? Okay, so we have general regression model, and this is what is we get expected value of y given x, alpha at plus beta at x1, and expected value of y is nothing but value of yi given xi. So this is expected value of y given x. So 1 into pi, 0 into this. So that means pi is equal to alpha hat plus beta hat plus x. So Jimmy, can you mute yourself? Jimmy, Mr. Jimmy, can you mute yourself?
Sir, I'm just muting. Just give me
one second, Nerija. Michael, one.
Saloni, you can also ask
Sir,
questions
I'm
if you want.
search. I'm unable to search his name. Just a minute.
Yeah, come over.
Please mute yourself, sir.
Come on. Kiva courage go. Kita win the
Can't you mute him?
Just a minute, sir.
Can't you mute him?
Just hala.
Saloni, can't you mute him?
Sir, I'm unable to find his name.
His name is Ruzi Jemika.
One.
So can you tell his name?
Zemika, Z-I-M-I-K.
That's a
Zemik, Z-I-M-I-K.
Done, sir.
That was good. Now, friends, look at this. What we are talking about is the estimated value of y is equal to alpha hat plus beta hat plus x. What is the meaning of this hat? Saloni, you tell me what this hat means. Saloni, are you there?
Yes, sir. Sorry, sir.
Saloni, what is this head means? Whenever somebody see head on a variable, what does it mean? Estimated value.
Estimate.
Yes, Prasanna, you're right. And the estimated value we get is the expected value of y given x, and that's equal to probability that y takes a value and this is the point which you have to keep in your mind. The resultant thing which you are getting is the probability that y is taking value 1. Is that clear? Let me make it more clear. And so we have a expected value of y given xi is equal to pi. So pi is equal to alpha hat plus beta hat plus xi, and this model is called linear probability model. Linear probability model. The estimated value is interpreted at the probability of having y as 1, and that's what it means. And beta represents the marginal change in the probability for a unit change in x. Okay, so we have y alpha plus beta x plus error term. This is my binary. The model is called a linear probability model. It's linear because the equation is linear, if you see. Why is it called probability model? Because the estimated value which we get, y hat, the estimated value that's equal to probability. And if you apply OLS, can you imagine the problems you will face? If we apply OLS here, can you imagine the problems somebody will be facing? And that's your regression line. This is your intercept, alpha hat, theta, tan theta is your slope. That's your beta. And this is your pi. This is your 1 minus pi. That's your expected value, which is equal to probability, and probability that y will take 1, probability that y will take value 0. Linear probability model. Can you imagine what is the input of it? We have dependent variable as binary. And of course, you have a number of independent variables. What is the output we get from it? Anybody? What is the output we get from here? Anyone quick? Output which we get is probability that y takes value and the method which we use here is OLS. But we face problems. Can any one of you tell me what problem you will face if you use OLS? Think. I mean, why there is a need to go for a special topic? I should have used OLS. And if I try to use OLS, I see a lot of problems in it. So can any one of you imagine what is that problem you will face if you apply OLS? Anybody? Anyone? Anyone like to say something? Pranay, can you try? Shifa, can you try? Sir, can you brief on OLS, sir? Rishika, what is your query about OLS? Oh, Ritika is saying the relationship might not be linear. Ritika, what makes you to think that relationship is not linear? If we have linear, do we face problem, Ritika? Prasanna, anybody explain what is OLS? Rishika, what do you want to know about OLS? OLS is ordinary least square method. Anyone who would like to say anything about OLS? Okay, what is the full form of OLS? Madhu, Manjari, Rajesh, Sudha, so many people are there. Yes, Ritika, I will come back to you. You have an absolute idea, and you are right. I'm not saying that you are not. You're wrong. I'm not saying that you're right, but how do you get that particular idea? Yes, sir. Chef Saifa. OLS stands for ordinary least square method. What it does? What it does? What it does? What it do? Estimate alpha and beta by doing what? It estimates alpha and beta. Regression method where dependent variable is continuous variable. No. Saifa, please don't generalize it in that way. How they estimate alpha and beta? They estimate alpha and beta by minimizing sum of square of error. And that's why it is called least square. It's minimizing the square of the error term and then determine the value of alpha and determine the value of the beta. And why do we use OLS? We use OLS because of its nice properties, which are called blue. What blue stands for, Ritika? Yes, Prasanna, what blue stands for? Prasanna, what blue stands for? Anybody? B for best, L for linear, U for unbiased, estimator. Yes, Ritika, you're right. OLS estimates are the best linear unbiased estimators. But there is a big but in it, there is a big condition in it, and that condition is that its assumptions are true. If the assumptions are true, then OLS estimates gives you the best results, and nobody can question the quality of the OLS. But the big question mark is about their assumptions. Okay, so I think this is giving you the answer. Rishika, is that clear? Anybody, any question? Okay. Let's see what problems it creates. So, as per the linear probability model, the probability increases with the value of x, or it may be decreases with the value of x, depending upon whether you have positive relationship or negative relationship. In that result, it might be possible that probabilities are becoming less than 0 and more than 0, more than 1. Because the moment you say linear, I cannot put a bound on it. It may go up, it may go down. If it is going up, it may be possible that it's exceeding 1. Going down means it may become negative. Ritika, now you take the clue for nonlinearity from here. The problem with a linear function is you can't stop it. If it is increasing, it will go on increasing. If it is decreasing, it will go on decreasing. You can't put a bound on them. And therefore, linear function is not an appropriate function for modeling this kind of a problem, where we have to go for particular kind of nonlinear function that will restrict my probability values between 0 and 1. Ritika, is that clear? Let's take another problem. Distribution of the error term is not normal because it's binomial distribution. Y is taking values 0 and 1, and therefore your error term will also behave in a binomial probability distribution manner. And what is the Variance of binomial probability distribution. Anybody? What is the variance of binomial probability distribution? Yes, Dr. Maya. NPQ. Great. What does it mean? When n increases, my variance increases. That means I'm not satisfying the condition of homoscedasticity. My variance changes with change in the value of n, the number of observations. It doesn't remain constant, and it creates a problem of heteroscedasticity. And if there is a problem of heteroscedasticity, your OLS estimates will no longer be true estimates. In the linear probability model, as we said, that it will continue to increase or decrease, and we cannot restrict their values between 0 and 1. Therefore, we need a non-linear relation. Can any one of you recall any function which takes value always between 0 and 1? Whether your x tends to plus infinity, tends to minus infinity, the value of y will always be lying between 0 and 1. So you have p here, you have x here. Whether x is going to plus infinity or going to minus infinity, the value of the p will always be between 0 and 1. It will not go beyond it. Prasanna, log is not there because log of a fraction is negative. So it takes negative value, not allowed. Log of 100, if I take base 10, it's 2. Taking value more than 1, that's again not allowed. Please appreciate we cannot use OLS for binary dependent variable model. If we do it, we are in trouble. What's the way out? We have to go for non-linear function. Which nonlinear function? That is something we have to think. How to ensure that the choice of probability value will always be between 0 and 1? For that, we have to use S-shaped function between x and 1. This is 1, this is 0. So the value will go something like this. What does it mean? We're looking for S-shape function. So this is my S-shape function. Not going beyond 1, not going below 0. It will be always lying between 0 and 1. Okay? So in this regard, we use two important functions. One, logit, and we get what is called logit model. And another is we can make use of standard normal probability distribution. and we get what is called probit model. So if I'm using normal probability distribution, I get probit. If I use logistic function, I get logit model. Okay. Z tending to plus infinity, tending towards minus infinity. What will be the probability of Z if it is tending towards minus infinity? I'm talking about cumulative probability normal distribution. Please come out quick. If Z is tending towards minus infinity, what will be the cumulative probability distribution? What will be the area under the curve? 0. And if Z is tending towards infinity, what will be your cumulative probability function? It will take a value 1. And your function will be like this. This is 1. Can anyone tell me what is this value? Anybody guess? Prasanna, can you try? Dr. Maya, can you try? Ritika? Saloni, you can also try.
Yes, sir.
What is this value? .5. And you know why it is 0.5? No, Dr. Shefa, it's not 0.75, it's 5. Because if you remember, Z0 divide the whole area into 2 equal parts. So one part 0.5, at another part another part is 0.5. So the distribution is dividing the whole area into 2 equal parts when Z is equal to 0. So this will be always 0.5. I give you a function 1 upon 1 plus e to the power x. If x tends to plus infinity, can any one of you tell me the value? What will be the value of 5 when x tends to infinity? Quick, think. Dr. Maya, Ritika, Rishika, Prasanna, Shifa, Saloni, Rajesh. So many people are there. Can any one of you give me the result? When x tends to infinity, what happened to y? Asha, yes. Asha is saying 0.5. Anybody else? Anybody else? Okay, I put it like this. This is equal to 1 over 1 plus 1 upon e to the power x. So when x tends to infinity, what happens? This becomes 0. And this becomes 1. And if it tends to minus infinity, then what happens? Dr. Maya, when it becomes minus infinity, then this will be plus infinity. Minus into minus infinity plus infinity, which is a very, very big number, and your y becomes approximately equal to 0. So this is called logistic function, whose values will always be lying between 0 and 1. Whatever value of x you take, From minus infinity to plus infinity, you take any value of x, result will always be between 0 and 1. Cumulative normal probability distribution, nonlinear, logistic function, nonlinear, and that's why linear probability model doesn't work. We have to think of some nonlinear function, and we have thought two nonlinear functions, one based on probability distribution, normal probability distribution, which gives us probit model, and the logistic function gives me what is called logic model. So now let's start with logic model. Logic model assumes that the underlying function is a logistic function, also called sigmoid function, and that the S-shaped function. Nonlinear, whose value will always be lying between 0 and 1. And that's how we get this. And probability is equal to 1 over 1 plus e to the power minus z. And z is equal to alpha plus beta x1 plus beta 2 x2 and so on plus error. What we do? We get an estimate of z, plug it here, and we get the probability. Please understand what I'm doing. I'm using logistic function, which is this. This is z, which is function. This is my binary. And these are my independent variables. Using them, I estimate the value, plug in here, and then I get the probability. Let me do little bit mathematics here. P is equal to 1 over 1 plus e to the power minus z. 1 plus e to the power minus z is equal to 1 over P. Then e to the power z is your P over n minus. P is the probability of success and 1 minus P is the probability of failure. P means probability of 1 and 1 minus P is the probability of 0. And suppose this is 3. How do we interpret this? Any one of you? Dr. Mai, can you speak out what this 3 means here? Sharmila, Asha, Ritika, Prasanna, Dr. Shefa, anyone? What this 3 means? Quick, tell me what this 3 means. Success is 3 times of failure. Probability of success is 3 times of probability of failure. Any one of you, what this called? If I say 2, that means success has twice chances of happening as compared to failure. What is it called? If it is 4, that means success is likely 4 times more as compared to failure. Anyone, why don't you people call me and tell me this is what is? So many participants. Sanjay Karan, yes, great. Coefficient. It's a coefficient of what? Sanjay ji, it's a coefficient of what? This is called odd ratio. Okay. Yes, Sharmila, very good question. You have raised if P plus Q is 1, then now it is 3. Okay. If P is 0.75, 1 minus P will be 0.25. So divide Sharmila, have we got 3 or not? Sharmila? Now, do you know how do we get this 3? So odd ratio is e to the power z. So probability is 1 over 1 plus e to the power minus z. E to the power z is equal to p over 1 minus p is equal to odd ratio. And if you take a log of it, if I take log of it, what I get? If I take a log of it, what I will get? Z is equal to log of p over 1 minus. So Z is nothing but log of odd ratio. And that's equal to your alpha plus beta 1 x1 plus beta 2 x2 and so. So please remember this, what we are discussing here. Let me summarize again. Probability is 1 over 1 plus e to the power minus z. E to the power z is log of, odd ratio, which is equal to p over 1 minus p, and z is equal to log of odd ratio. Please note this because all these three you will be using for interpretation purposes. Remember these three things, and it's better if you note it. If any one of you have any doubt, please let me know. Okay. So Pi is this, where Z is equal to this. And sorry. So we can show that odd ratio is e to the power z. And if I take log of odd ratio, I get z. Yes, Sharmila. My logistic function is Pi is equal to 1 plus e to the power z. This gives me probability. If I want odd ratio, odd ratio will be e to the power z, which is equal to p over 1 minus p. If I want z, then my z is log of odd ratio, which is equal to alpha plus beta 1 x1 and so on. Yes, Sharmila, is that clear? This is 1, this is 2, this is 3, which you have to do. Anybody, any other question? Please. Rashika, you tell me, you want to see the impact of the financial literacy on investment decision, right? So investment decision is what kind of a variable you're using to represent investment decision? Yes, Rashika. Rashika, you can unmute yourself and talk to me. Rashika, that's not the question I'm asking you. Non-metric, metric, that's not a question. Give me the name of the variable you will be using to represent investment decision. Okay, no problem. If you're not able to mute yourself, no problem. Saloni, have you muted everyone?
No, sir, the settings are on. Anybody can unmute.
Okay. Rashika,
I'll still send you the request to unmute, sir.
Rashika, again, I'm asking you the variable which represents, I need name of the variable which represents investment decision. Whether it is metric, non-metric, that's a different question. But what is the variable you are using to represent investment decision?
Sir, variables like risk-taking ability, liquidity.
But they are all scale. They're not binary. Dependent variable is your investment decision, right?
Yes, sir.
Liquidity is scale. You cannot use logistic. Risk is also scale. You cannot use logistic. You have to think of a variable which is binary. Only then you can use logistic, otherwise you cannot.
Sir, but financial literacy, in review of literature, I've seen that in while checking the financial literacy, they have used logit and probit regression model.
So that's why I'm asking you, what is the dependent variable they have taken? The The variable which they have taken must be binary.
Sir, then in this objective, we can't use logistic regression.
Pardon?
Sir, in this objective, we can't use logistic
No, we
regression.
cannot. We cannot.
Because sir, here independent variable is financial literacy, and that is binary. Not
Doesn't matter. Independent variable, whatever it is, it doesn't matter. You can still use OLS.
Sir, if we are just checking the financial literacy of an individual, then sir, can we use?
Ritika, you have to be very clear about what is your dependent and what is your independent. If you are just checking, you are not establishing causal relation. Sharmila, debt equity ratio again is not a binary variable. Ritika, yes, binary will be yes or no type of variable. You have to think. And that's how we get the log of the odd ratio is by z. How do we estimate logit model? The method which we use is maximum likelihood method. The estimates we obtain are known as the maximum likelihood estimates. And if you make use of cumulative probability distribution, then we are using probit model. So again, you have to calculate Z and put it in the, or refer to the table of the normal probability distribution to calculate probability distribution. Can we predict who's going to have value 1 and who's going to have value? If you get a value 0.71, the respondent 1 gives you value this. Where you will like to put? 1 or 0? Where you would like to put 1 and 0? Anybody? Dr. Mageshwari, you are able to hear me? Anjali, Sanjay, all are saying put 1. But how do we decide what should be my threshold? So normally we take 0.5 as a threshold. Any value less than 0.5, 0. Any value greater than 0.5, but you can change the threshold, but normally that's the limit which we take 50%. Less than 50%, 0. More than 50%, 1. Once a logit or probit model is fitted, then a question arises. How do we know whether my model is a good fit model or a bad fit model? How do we know it? How best is the model? How do I know whether my model is a good model or a bad model? Tell me indicators. Tell me the indicators. 0, 1 model, dependent variable model, whether you use probit model, logistic model, how you will come to know that my model is a good model than the others. RMSEA. Rashika, this is used when you do the forecasting. We are not doing forecasting here, so we don't consider it. Think something else. Can we use R square or adjusted R square for determining the goodness of it? Answer is no. Can any one of you tell me why I cannot use R square or adjusted R square? Why we are not using R square and why we are not using adjusted R square? Can any one of you think? Because we are not using OLS. Ritika, we are not using OLS, that's why we are not using R square and adjusted R square. We are using maximum likelihood method, which doesn't give R square and adjusted R square. Then what should we do? We use something similar to R square, which we normally call as a pseudo R square. And log likelihood functions are also used, and the softwares will give you the -2 log likelihood values. Lower it is, better it is. Then we use log likelihood ratio, which is calculated like this. I'm not going into the mathematics of it, but log likelihood ratios are used for getting an idea about the goodness of it. Lower are they, better the fitness. And if I cannot use R square, then we use what is called pseudo R square. They're not R square actually, but they mimic R square. And the most famous and the widely used is called McFadden's R square. Higher it is, better it is. Its value like between 0.2 to 0.4 are considered highly satisfying. But again, these are thumb rules, not based on any scientific reasoning. Then another measure of pseudo R square is Cox-Snell R square. And then another one is Nagelkar K measure, which is also gives me R square. And beside that, you can make use of information criteria, AIC, BIC. Lower they are, better it is. So you can make use of information based criteria. So what we have discussed so far, binary dependent variable. For this, OLS cannot be used. If we saw a problem, then we use logistic or logit model, and we estimate this model by making use of maximum likelihood method. And we have also discussed the measures of goodness of fit. And we also saw that if we take 0.5 as a threshold value, then we can we can classify our variables into 0 or 1 group. Any questions here? Any doubt? Any query? If you have anybody, any doubt, any query, any questions? Please, my request to all of you is don't hesitate. Any doubt, whatever it is, please throw it out so that I can address that issue. No questions? What next? Next is time to take a break. So let's take a break. So we will come back at 6:45. Saloni, is it okay?
Yes, sir, absolutely okay, sir. 6:45, I'll write in the chat box also.
Right. Saloni, should we start?
Yes, sir.
Okay. Saloni, Saloni, Saloni,
Hanji, sir.
you
Hanji,
have
sir.
also the right to
Sir, am
ask.
I audible? Definitely, sir. Definitely.
Don't hesitate.
Hanji, sir.
So, friends, welcome back, and let's continue with our discussion. Anjali, when I say model, that means the regression model which you have developed for logistic purposes. You have to estimate that, and once you have estimated that, you have to look for goodness of it. That's what I mean when I said after the estimation of the model. Anjali, that clear? Okay. Saloni, check whose mute, whose audio is open.
Hanji, sir.
Check that. Friends, again, I ask you a question. If you have a question, any doubt, anything that came to your mind during the break, really, I don't know, like methodology design, I don't know what do you mean by this, like in methodology design. Now let's see whatever we have learned, let's apply it and try to do it. I will be doing on Stata as well as on SPSS. So let's take an example. A survey is conducted among users and non-users of microwave, and we got the data: users and non-users, users 1, non-users 0, monthly income and monthly consumption of the food items. So my model is users, to alpha plus beta. Dr. Sanjay Kumar, can you mute yourself?
Done, sir.
2 consumption plus, where this is my binary. So this is the model which we have, and we are using logistic regression. How do we do it? That's the data which we have with us. Okay, so let's see how we can do it. And in these are the commands of state are very simple: logic, dependent and independent variable, predict, probability, classification, statistics, marginal analysis, and you can install fit stat to get the all fit statistics. Okay, so but I think let me first show you how can we do it in uh, if you people have the spaces or data with you, you can do along with me. Files I've already shared. Saloni, have you
Sir?
forwarded the files?
Yes, sir.
Okay. So
सर
let me
कल की तो फाइल नहीं आई थी,
अंजलि को दिया
आज
मैंने,
की क्लास की तो फाइल नहीं आई
अंजलि को
थी।
दिया मैंने।
पहले जो आपने भेजी थी वो सारी भेजी हुई हैं।
अंजलि से पूछो।
ये
Sir, no files.
नहीं
We
सर,
have
लास्ट तो वो
we haven't received any
मनोवा
files.
मार्केटिंग स्टाइल वाली नहीं सर, ये वाली फाइल्स नहीं आई। मैं
अंजलि
पूछती हूँ मैम।
हाँ।
हाँ जी सर।
So friends, let's import the Excel file. Browse. We have first row is my variable. Yes, Ilana.
सर अंजलि मैम is sharing the files.
So if you want to see the data, I just put edit and you can see the data. So we have consumers 1, non-consumers 0. This is the monthly income and this is the monthly consumption. So let's see, how do we estimate this? Very simple command. You have to just write logic. Your consumer is your dependent variable and monthly consumption and income, your independent variable. And that's the result which we get. I show you how can you do in SPSS. So data and the type of the file is Excel. That's the data which we have. So go to analyze and your regression, binary logistic, analyze regression, binary logistic. Click on it. Asking for dependent variable, consumer is my dependent variable, monthly income and consumption my covariates. I think options. You see, if you want to see the classification plot, you can have the classification plot. Continue. Then you say okay. And that's the result which we get. I just put it in Word so that we can see it clearly. So first, let me write the equation. My equation is consumer is equal to 0. Minus 18.493 constant plus 0.333 income plus 0.193 consumption. This is my equation. Consumer is equal to this, and both coefficients are significant. You see here. And their positive impact. What does it mean? What does it mean? It means that if income of a family increases, consumption increases, the chances that a person will use microwave, that increases. That's how we interpret this. And both the variables are having significant impact on the decision whether a person will be using microwave or will not be using microwave. Is that clear? And you must have seen we are getting the same results here as well. they are again coming to be significant. And this is the log likelihood value. And that the pseudo R square, which is sufficiently high. That means my model is satisfactory model. Friends, I'm not in a hurry, but what I want that any input, which any result, any part of the result, you think you need to discuss with me, please don't hesitate. Is that okay? Right. Now let's estimate the probability. Sharmila, just wait. I will tell you the pseudo R square. So I want to estimate the probability. So we say predict. This is the variable name, comma, P is for the probability. This is the command. This is your name. And you can give any name, whatever you wish. And P is the instruction to the stata that estimate the probability. Just give me an example. Just give me some time. I will come back to your questions. Dr. Deepthi, Sharmila, just wait. I will come back to your questions. Then you say enter. And you see that you got the estimates of the probability. These are the all estimates of the probability. If you want, suppose I want to estimate the probability for this case, 15 and 65. So what I do is I can copy the data from here. I put it in Excel. And just taking some time to open up a calculation I can do in Excel. I take probability values from here. Just a minute. Hello? Yeah. तो मुझे राइट दे दो तो मैं फिर मीटिंग ऐड कर दूंगी तो ध्यान रखो ठीक है These are the values of the coefficients which we have. And I want to find the probability for 15 and 62. Monthly consumption 15 and 62. So it's 1. I can get the value of Z. That will be equal to some product of these with these. Any one of you remember how do we get the probability? Probability is equal to 1 over 1 plus e to the power minus j. One over 1 plus exponent minus the value of the z. That's how we calculate the probability, and we can verify probability from here. You can see here 1.746. There is a difference because I've taken some, not the complete value, some fractional approximated value. That's why I'm getting this relationship. And if you take 23.4 and 54, 23.4 and 54, I get probability 0.43. The difference is because of the fact that I've taken the fractional values. If I take the full value, maybe my results are same. I think I have written wrongly. Consumption. So friend, that's how you can calculate the probability, and in SPSS also you can get the probability. I show you how can you get it. Save probabilities. Continue. Okay. And if you see the probabilities are being saved, probabilities are being saved. That's how the probabilities are being saved. Okay. For getting the other statistics in data, we have to use this. We have to install a package which is FitStat. So you write a command here, ssc install FitStat. Then you simply write FitStat, and that's what you get. Pseudo R square, which is being reported here, is nothing but your the McFadden's R square is what we get here. So pseudo R square is similar to R square. It's miming R square, but actually it's not R square. Higher this, that means my model is a good model. Okay. Now, Dr. Deepti, I'm taking your queries. Okay. Log likelihood function. Actually, this is coming from the fact because we are using maximum likelihood method. And if you see this maximum likelihood method, now see what is happening here. If there is no variable in the model, this is what we get. Dr. Deepti, tell me, is -3 is greater or -2 is greater? Dr. Deepti,
-2 is.
that means what is happening here? It's reducing. The negative value is coming down. That means what? That means what? I'm maximizing my likelihood function.
Yeah.
Okay, so after iteration 3 and 4, 5, it's almost same. So we cannot further, increase it. So that means my model is giving me maximum likelihood function, and that is better model. Lower it is, better it is. Chi-square is like your F-test in the OLS. So if it is coming to be significant, that means your model is explaining the variation which is happening in the probabilities of, dependent variables.
Okay. Sir, what are the things we need to report in our paper?
I'm coming to that. So These are the fit statistics which we have here in detail. The McFadden's and information criteria we have, and this is the McFadden's adjusted R square. A lot of things are being given, so we don't report all of them. Okay. Now, question is, what is that which we have to report? Okay. So, of course, you have to report the model, which is this. And you can also report the standard errors, and you can put a star whether they are significant or they are not significant. Okay, then no need to report them. You can report only the number of course, you can report only the pseudo R square. That is acceptable. So nothing else you are supposed to report.
Okay, sir. Thank you, sir.
Okay.
Okay, sir.
And if you want to see the change, you can also find the change by using the command of margin. If you want to see the classification, so E stat classification. Prediction is being done by considering the threshold 0.5. Overall success rate is 83.33%. That means our model is able to classify so much correctly. Okay, that's your success rate. Then individually you can also find out when it is true. This is one. This is your false rate. And if it is, this is your false rate. So practically 20 out of 24 is your success rate. Out of 24, you are able to rightly classify 20. So you can calculate this. 20 divided by 24. And you will see this. Only in 4 cases out of 24, our prediction was wrong. 83.33% our prediction is correct. So higher the correct prediction, higher the success rate, better is also your model. So Dr. Deepti, you can also report your success rate or right classification rate in your paper.
Okay, sir.
Let's take one more problem and see how we understand it. Doing research, want to know what determines whether a firm will have a strong brand or a weak brand. And for that, he collects information about profit margin, market share, and size of the firm. And you will see firms are having strong, firms are having weak. Clear-cut mark grouping you will see. And what will be my model? My model will be brand, which is binary, weak, and strong. That's equal to alpha plus beta 1, your size, plus beta 2, market share, plus error. I think one more variable is there. So that's how you will make the model. Okay. And let's see, how do we get the results? So I again go file, import, browse, brand data. Then logit will be equal to your brand size market profit. That's the result which we get. And you see, started with minus 51, gradually reduced to this much. And that's your log likelihood one. Significant, model is good. McFadden's pseudo R square is also very high. That shows your model is a good model. And my question is, brand is equal to 3.42 size. I'm taking up to 2 decimal plus 0.23 market share plus 0.46 profit margin minus 13.5. That's my model. And all the variables are coming to be significant. That shows my model is a good model. Then we can estimate the probabilities. Just a minute. Just give me a minute. Lot of files are opened up. I don't know what is happening here. You can get the fit stat. You can predict the probabilities. You can see the probabilities. These are the probabilities which we get. You can also get the success rate in stat classification. That the classification. All these statistics you can get from here. So these are the variables. These are the coefficients which we get. These are the, pseudo R square. And that's how we get the probability Z by using that function. Z you can estimate from the equation and plug this Z to get the probability that will be equal to 1 plus e to the power minus Z. Which one we should use? Probability or logit. You will find these days logit is more used because whenever you are using probability model, you have to refer to normal probability distribution tables again and again. Logit comparatively more simple in terms of its mathematics, and therefore logit model is widely used as compared to probability. Though you may not get the different result, you will get by and large same results from both the models. The assumption which we make for our model is dependent variable is binary. Observations in the data which we get, they are independent of each other. No collinearity between variables. Logit model assumes that the independent variables and dependent variables are non-linearly related. But independent variables and log of odd ratio are linearly related. Sample size should preferably be large. These are the assumptions which you make. What assumptions we do not make are the following. Does not require linear relationship. We are not assuming that error term need to be normally distributed. And assumption of homoscedasticity is not required. So what assumptions we make, what assumptions we don't make, these are the things before you. Now the question is, what is the relation between this and this? Let's take them in detail. I take this equation. just put it in the word so that we can enlarge it and show it in a bigger way. Right. So let me write the question. The question is my brand is equal to minus 13.95 plus 3.42 size plus 0.234 market share and 0.4639 is your profit margin. What is the interpretation of it? Anybody? What does it tell us? What does this tell us? What does this tell us? Anybody? Don't allow your energy to go down, please, quick. What is the interpretation of these coefficients? What they mean? First, let's look at their sign. Positive, positive, positive. What does it mean? What does it mean? Higher the size, higher the market share, higher the profit margin, stronger will be the brand. Stronger will be the brand. Ritika, 3.2 time chain in dependent variable. But what does it mean? When you say brand, what does it mean? Ritika, what does it mean? 3.42. What does it mean? No.
Sir, it means it is the beta of size, and it will create 3.42 times change in
What?
um,
Change in what?
yes. Sorry, sir, not getting.
Anybody else? Maya and Deepti, percentage point stronger. No, Deepti doesn't mean that. If you remember, probability we get 1 over 1 plus e to the power minus z. E to the power z is my odd ratio. And z is what? log of odd ratio. And it is in this sense we have to understand. It is in this sense we have to understand. So that means what? If we are increasing size by 1 unit, then log of odd ratio will increase by 3.42. That's what it means. Is that clear? Similarly, what does it mean? If my profit margin increases by 1 unit, my log of odd ratio will increase by 0.4639. So which is having more impact? Size is having more impact on the odd ratio. Size makes more impact on your stronger brand as compared to market share and profit margin. That's how we interpret this. Please don't interpret this 3.42 will be impacting my probability. No, it's not that. And if you want to get the odd ratio in Stata, you simply write, sorry, you simply write OC for OR for odd ratio. And you get the odd ratio. And these odd ratios are nothing but what is the odd ratio? How do we get the odd ratio? Odd ratio is e to the power z. E to the power z. So if I take a exponent of z, if I take exponent of the z, sorry, if I take the, if I display exponent of size coefficient, you will get the odd ratio. That's how we get the odd ratio. So exponent of Z will give you the odd ratio for each one of them. And this is having higher odd ratio. That means if by increasing size, you can increase the probability of making your brand stronger. That's what it means. Okay. So the question is, what is the relation between profit margin, market share, probability that a firm will have a, okay. Anjali, what is the probability of getting ahead? Probability of getting ahead? 0.5. Probability of getting tail? 0.5. थोड़ी देर में कॉल करता हूँ. Deepthi, we can report dy dx, and how do we get dy dx? I'm coming to that. Just wait. So I was explaining what is odd ratio. So the chances of success head and the chances of they are equal. 1:1. That means getting head, the odd ratio is 1. When you say odd ratio is 1, there are equal chances of getting success and failure. Okay. If I make it 0.8, 2, so what is the proportion between them? Success 4 times as compared to failure. So odd ratio is 4. That means you have 4 times more chances that you will get a success as compared to the failure. So that's what this ratio, odd ratio, stands for. Again, odd ratio tells you the proportion of success vis-a-vis with failure. So if you have a 0.6, 0.4, what does it mean? 1.5. So odds, 1.5 odds are there in favor of success. So failure is getting 1 chance, success will get 1.5 chance. That's what it means. Okay. Dr. Deepthi, just give me a minute. I will come back to you. How do we get dy dx? So though there is a nonlinear relationship between probability and independent variable, yet the sign of the coefficient shows the direction of the relationship. So if the coefficient sign are positive, that means that particular variable is having positive impact on the probability of success. If it is negative, that means it has a negative impact on the probability of success. And that's how the probability is increasing, giving you S-shape. That's for profit margin. And how do we interpret beta? Beta represents effect of a unit change in X on the predicted value of logit, that is log of odd ratio. So if my market share increases by 1 unit, my log of odd ratio will increase by so much unit. That's what it means. Okay. Second, exponent of the beta value, which we got, this is nothing but odd ratio. Represent how 1 unit change in an independent variable will cause a change in the odd ratio. If the beta is positive, the exponent of the beta will be more than 1. If it is negative, it will be less than 1. The change in the odd ratio for a unit change in independent variable will be the times equivalent to so much. That's how you can find out. So the interpretation of this odd ratio is, if size increases by 1 unit, my odd ratio changes by so many units. If my profit margin increases by so much, my odd ratio will increase by so much. Then, how do we get the dy dx? Now, Dr. Dipti, I'm taking your question. Dy dx can be calculated like this. Beta I into probability and 1 minus probability. And it's non-linear, so it will change for all probable values. And if you want margin, you can calculate margins by using the command. I will show you the command. Margins, comma, dy dx. The name of the variable you can get at means, or you can get at the different values. So dy dx will give you the change in the probability. Okay, I show you how we can do that particular. So you have to write margins, comma, dy dx. Suppose I want with respect to size at means just a minute. So at means is one word, that's what we get. So this is the probability. dy dx is the change in the probability at mean this but if you want probability dy dx at a particular value, you can mention that particular value here. And how can you do that? I show you. Suppose I say size equal to 20, profit margin equal to 12, market share equal to 10. I think I have to check my data. The size is 0, 1. That's the probability you can get. So, Dr. Deepthi, since it's a nonlinear function, probable dy dx changes with every point. So, that means you can report, but not for all values. So, normally we report marginal analysis at means. So, that you can do, that you can report. So you can report dy dx. If you want for all, you can write all. So there is a space in it. So you get the dy dx of all the variables at means that you can find out. Is that clear, Dr. Deepthi? If you still have a question, you let me know.
So, sir, it's clear, sir. Thank you, sir.
Okay. And if you want to calculate probability by using your own calculation, that's the formula you can find out dy dx. Okay. So, friends, whenever you work with the logit or probit model, first thing you have to define your model. Like in a brand case, we say brand is equal to alpha plus beta 1 size and others. Then estimate model, we use estimate model using maximum likelihood logit model. Then we do marginal analysis for some specific value you want to do, you do it. But otherwise, for reporting purposes, we do at means. And whatever inferences you want to get, you can get the inferences. So these are the things which we have to do for our logit and probit model. So friends, I don't know whether it really become difficult for you to comprehend it, but I think most of you must have got a good feel about logic. Anyone finding any difficulty? Any questions if you have? Please don't hesitate. I tell you, logistic regression is widely used in data analytics. Whether a customer will buy any product on a consumer e-commerce site, to model that and predict that probability, they work with logistic regression. There are huge application of logistic regression in the real life, you can see. Anybody having any other question, any doubt? Please don't hesitate in asking questions. Make sure that, I don't know to what extent you people are able to understand and appreciate this. Any question, anything? Dr. Maya, Dr. Shafi, Saifa, Vikram, Sanjay.
We understood, sir. No questions.
That's great.
Thank you, sir.
So that's all, friends. I want to discuss in this particular session, and I want to cover the multinomial, but we don't have the time to cover the multinomial. Whenever I get the time, I will definitely touch upon it. Okay, so that's all from my side. Thank you very much. Enjoy. Have a